how we're gonna do the writing equations lab. There's two parts to it. The first one, you read through the introduction. The introduction is going to tell you how to. It's going to talk about a couple different types of reactions. You have combination reactions. You're just taking like two things, combining them together to make one big one. Decomposition is kind of the opposite of that. You're going to start out with something big and split it up into something small, or split it in half there. Combustion is when you have a hydrocarbon. You can have other things in there too. The trick to combustion is that you're reacting with oxygen, and then you always get the same products: carbon dioxide and water. If you have something over here, if you have nitrogen, then you'll get a nitrogen-containing compound. We're just going to deal with these hydrocarbons, and we're going to assume we have complete combustion so that we don't make any carbon monoxide. All of our carbon is going to go into carbon dioxide and water. So you always get the same products. So for the combustion reactions, they might just give you a hydrocarbon, carbon and hydrogen, or sometimes there's oxygen as well, and just say it burns in air, or it's completely oxidized. And those are like keywords to let you know that you have a combustion reaction happening. We also have single replacement. Single replacement reactions are when one element replaces another in this reaction. So here we have zinc is going to replace the chlorine. Zinc is going to replace the hydrogen. Hydrogen is going to go off by itself. Or here we have two metals. So we have aluminum is going to replace the nickel. The nickel goes off by itself. And there's some rules for that. You need to look at the activity table. We'll talk about that. This is all stuff that we've done in class as well. And you have double replacement reactions where you have two ionic compounds. You have like A, B, C, D, and you have your cations and your anions, and the anions switch places. So I usually just write the cations back over here and then switch the anions. So I have lead, I keep lead there. Sodium, I keep sodium on that side. And then the nitrate ion and the chloride ion switch. When you put them over here, just make sure that you put their charges up here so you can figure out how many of each element you need. So don't just blindly copy this 2 over here. See how there's no 2 over there? Because there's a 2 here because I have lead 2+, so I need 2 nitrate ions here. Sodium is a +1 charge over here, so I only need 1 nitrate ion to balance that out. Then I balance the total number of ions with the coefficient out in front. But I don't want to just copy over, parentheses 2 here. That wouldn't be right. Because that would not be a neutral compound. When you're forming ionic compounds, you want them to be neutral. It's the same thing here. You just did a double replacement reaction. So you're going to fill out this table. It's the first part, and this is all also located in a separate data sheet. So everything's in one data sheet under the report tab. So something like this. So it says a combination reaction. You're going to have to read these. So this is going to be an exercise in reading, and you're going to have to you may have to erase something. If you just start writing out the compounds and you didn't read the sentence, you'll have no idea what's going on. So like diphosphorus trioxide. Diphosphorus, that means I have 2 phosphorus, right? Diphosphorus trioxide is O3, and it says it's formed from its elements. That means this is my product. I'm going to make P2O3, and I'm going to make it from its elements. So I have phosphorus and then oxygen, but oxygen is diatomic, right? Oxygen's diatomic, so it has a 2 at the end. And then I just have to balance this. So I have 2 phosphorus over there. I'm going to put 2 over here. I have 3. Oh, so if I put a 3 over here, I end up with 6 oxygens. So what I'm going to do is put another 2 in front of here. Now I have 6 oxygens, but that just messed up my phosphorus. So I'm going to change this guy to 4. See how I erased something there? I want to show you guys it's okay to start at one place and erase. That's balancing is best done in pencil for sure. All right, so then you just double check. I've got 4p, 4p, 6 O's, and 6 O's. Remember, you're multiplying the coefficient by the subscript. So in the first part, you just have combination reactions, you have decomposition. So you're going to start with something big and split it up into smaller pieces. You have combustion. So in a combustion reaction, you're going to take, C3H8 burns in air, means I have combustion, means my other reactant is oxygen, and I'm going to make carbon dioxide and water. And then you want to balance and make sure you're able to balance that up. I usually start with the CHO method. So I start with carbon. I have 3 carbons. I'm going to put 3 carbons over here. And then I have hydrogens. I have 8 hydrogens. I have a 2 over here. So I'm going to put a 4 in front. That gives me 8. And then I can balance oxygen at the end because this guy doesn't have any oxygen, so it's easy to balance that at the end. I have 6 oxygens from this carbon, from carbon dioxide. I have 4 from the water. That gives me 10. In order to get 10 oxygens over here, I'm going to put a 5. And then just double check. I got 3 carbons, I've got 3 carbons. I've got 8 hydrogens, I've got 8 hydrogens. I've got 10 oxygens, I've got 6 from here, and 4 from there gives me 10. Combustion reaction, single replacement, double replacement, right? And then they're all mixed up. There's a lot of these. If you finish this lab, there's really not much I can give you to trick you up. The second part of the lab involves net ionic equations. So net ionic equations, usually we're doing a double replacement or a single replacement reaction, and then trying to figure out what kind of species are present in there. So how do I break this down? I have to use my solubility rules in order to do that. Sometimes we make gases. So this is a cheat sheet for the solubility rules. So you can kind of check on here and say, all right, well, barium and carbonate. So barium carbonate, that's going to be a solid. Calcium carbonate, that's going to be a solid. If you look at this, if you go down carbonates, there are a lot of solids there. Hydroxides have a lot of solids. So we have solubility rules that are in the chapter, and then this is like our cheat sheet. So you can use either one. That's perfectly fine. These are the solubility rules. These are ones that you should start to try to memorize. So these are usually soluble. These are some exceptions. When are these not soluble? Well, silver chloride, silver bromide, those are not going to be soluble. That would be a solid. So that would stick together. It wouldn't dissociate into ions. We also have some strong acids versus weak acids. The strong acids are going to dissociate into ions. Those are our strong electrolytes. The molecular ones are going to stay together. We will form some gases, liquids, and so there's a couple of specialized reactions. So make sure you read over this procedure a little bit when you're doing this before you just jump right into writing the reaction. So if you go back to the equation sheet, scroll down, 6b is just writing net ionic equation. So let's write one. Let's do one. Sure. All right. So we have lead 2 nitrate. What is that going to look like? Lead is Pb2+, nitrate is NO3-, and magnesium is Mg2+, sulfate is SO4 2-. This is so much easier when you know all of your polyatomic ions. So here I have a cation, I have a cation, so on the other side of this, I'm going to have my Pb2+, and my Mg2+. Okay, so I just wrote those in the same order that I had them, and then I'm going to switch their anions. Now, lead had nitrate before. Nitrate's going to go with magnesium over here. So I have nitrate, NO3-, and the sulfate was with magnesium. Now the sulfate's going to go with the lead, SO4 2-. Okay, so now I'm going to crisscross applesauce write my molecular equation. Crisscross here. So lead 2 nitrate looks like Pb NO3 2. Crisscross. Yep. And magnesium sulfate is just MgSO4 because I have a +2 and a -2. I need this 2 here, right? Because I'm bringing this superscript down here. And this is just 1. And then on my other side, I have lead 2 sulfate. I have a +2, -2, so that's just PbSO4. And then I have magnesium nitrate, NO3. Since I want 2 nitrates, I'm going to put a parentheses and then a 2 after that. Great. Now what do I have to do? Now I have to figure out who is soluble and who is not soluble. So nitrates are always soluble. So anytime I see a nitrate, I know that that's always soluble. If you remember the solubility table, that's true. Solubility table. So a couple things you could do at this point. You could grab the solubility rules. Right, solubility rules. Nitrates, there's no exceptions. Nitrates are always soluble. So whenever you see nitrates, you're good to go. The other thing we have in this problem is the sulfates. And sulfates are usually soluble, except when you have strontium, barium, and lead. Okay. So in this case, we do have lead. So we know that lead sulfate is going to be our solid. But magnesium sulfate will be aqueous because it's soluble. So aqueous means soluble, solid means it's a solid. So the next step now is to split up anything that is a soluble ionic compound. So we're looking for strong electrolytes. Strong electrolytes are soluble ionic compounds. There's strong acids, strong bases. All of the strong bases are soluble ionic compounds. So these are all ionic compounds. I have a metal and a group of nonmetals. I have a cation and an anion. So anything that's a soluble ionic compound, a strong electrolyte, I'm going to give it a star. This guy gets a star. That means he's going to dissociate into ions in the next step. This guy gets a star. I'm going to dissociate him. This guy's going to stay by himself. He's a solid. He's not a strong electrolyte. He's not a soluble ionic compound. This guy is. He's a soluble ionic compound. Soluble means aqueous. Ionic means it's a cation and an anion. So anybody that has a star there, they're going to get split up into ions. All right, so now I'm going to have my lead 2 nitrate. I'm going to split that up into lead, Pb2 plus 2 nitrates. So see how I brought that subscript out in front? Because lead 2 nitrate, if you really think about a picture of what that looks like, I have lead 2 plus, and then I have nitrate and nitrate. So what I'm doing now is saying when I have lead 2 nitrate in an aqueous solution, so once I put that in water, it splits up. It splits up into the lead ion and then 2 of these nitrate ions. So it just completely dissociates because it's a strong electrolyte. And that's what strong electrolytes do. They dissociate into water. They dissociate into ions when they're put in water. So these are all aqueous. You can continue to write aqueous if you want to. Now, magnesium sulfate, also strong electrolyte, soluble ionic compound. It's going to split up into magnesium ions and sulfate ions. And then over here, this guy stays the same. Just keep him together. Don't split them up. That's important. That's what we're making there. That's the solid that we're making. Whoa, lost it. And then magnesium nitrate, that's going to split up. So I'm going to split that up into magnesium 2 plus and 2 nitrate. So I bring that 2 out in front again. Am I balanced here? Did I forget to balance? I forgot to balance in that first step. You want to always make sure that you balance. So let's go back to that first step and just make sure. So I have lead, lead's balanced. I have 1, 1. Sulfate, I have 1 sulfate, I have 1 sulfate. I have 2 nitrates, I have 2 nitrates. You don't always get that lucky. So this time we didn't really have to balance. Make sure you don't skip that balancing step. You'll know that it's not balanced at this next step when you get to here and you start canceling things that are the same on both sides. And if something doesn't cancel, suppose I had like 1 nitrate here and 2 nitrates over there, that should be a tip off that I forgot to balance. But here I have 2 nitrates, 2 nitrates. I have a magnesium ion, magnesium ion. So what's left over? I have lead and I have sulfate. So I have lead 2 plus. That's this. Now I'm finalizing the net ionic equation. So this first one that we wrote, that's our molecular. And then the next one is our complete ionic. We showed all the ions in solution. And now the net ionic is like what's actually reacting. Where's the reaction happening? So it's happening between what species are involved. I have lead ions, I have sulfate ions that are involved in this precipitation reaction. So I'm taking aqueous lead, aqueous sulfate. When they find each other, they really like each other and they form a solid. And there we go. That's our net ionic equation. The spectator ions are the things that we just canceled. So we canceled nitrate. Nitrate's a spectator ion, and magnesium's a spectator ion. Good. So that's an example of one. Everyone's going to get that one right. So that's one. And there are a bunch of these. I think there's about 20 of these net ionic equations that you're going to write. So that's what we want to do there. Write out the whole net ionic equation. So the first part, you're just writing, reading the words, making the reaction. And the second part on net ionic equations, you're actually taking the words, writing the complete, the conventional, the molecular, and then writing the ionic and then the net ionic.